We use coordinate systems to help us accurately position different points on the Earth's surface and determine their accurate locations. Coordinate systems are used by a variety of GIS tools such as satellite sensors, GPS devices, and navigational instruments. Coordinate systems help us in the creation of maps and are used to actually position different Earth's surfaces. Although the Earth may seem round, in reality it's not really round as it bulges toward the equatorial regions and flattens toward the poles. Coordinate systems help us with different mathematical transformations to actually position different points on the Earth accurately, giving due considerations for space, time, and angular movements. A line running through the Earth that divides it into two equal parts to the north and to the south is known as the equator and is measured 0 degrees from north and south. Another major line which runs from north to south is known as the prime meridian and it divides the Earth into two equal parts, east and west. The prime meridian is essentially a line of longitude which runs from the geographic North Pole, which is at 90 degrees north of the equator. And at the other end of the prime meridian is the geographic South Pole, which is at 90 degrees south of the equator. The equator is a line of latitude, and lines of latitude increase towards the poles from 0 degrees to 90 degrees. The prime meridian is a line of longitude, and it increases in degrees to the east, which is measured positively, and measured negatively to the west. We can distinguish between two major types of coordinate system. The geographic coordinate system is based upon the degree, minutes, and second system, which measures angular movement of coordinates around the Earth. So essentially, it consists of lines of longitude and latitude measured as angular changes around the Earth in longitude and in latitude. Every line of longitude is essentially a prime meridian, which are used to measure longitude in degrees around the circumference of the Earth, and these lines of longitude converge toward the poles at the north and the south. The lines of equator is a parallel and is also a line of latitude, and all these lines of latitude are parallel to each other, decreasing in circumference and increasing in angle towards 90 degrees at the poles north and south. When we bring together the prime meridians and the lines of latitude or the parallels, we have a reticular network which form the basis of the geographic coordinate system. The projected coordinate system or the XY system is being used to project the curved surface of the Earth onto the planar surface. Many of the maps that are made work with projected coordinate system as they help to accurately position curved surface of the Earth onto flat surfaces. The coordinate system of the projected coordinate system is measured relatively in x and y values in meters from a defined origin. X and y could be positive or negative depending on the positions in the various quadrants. You can distinguish between the degree, minute, and second system and the projected coordinate or XY system in a variety of ways. In the degree, minute, and second system, 1 degree of longitude represents 1/360 of the Earth's circumference, and 1 minute of longitude represents 1/360 of a degree. 1 second of longitude or latitude represents 1/60 of a minute, and essentially, using the degree, minute, and second system, you can measure longitude and latitude in degrees, minutes, and seconds depending on their relative position from an origin. So we measure longitude east and west of the prime meridian, and we measure latitude north and south of the equator. In the projected XY coordinate system, X measures navigation distance horizontally from the origin, and Y measures navigation along the Earth's surface vertically from an origin. Both can either be positive or negative, and they can also be decimal integers.